Hello class. So I've noticed like a lot of you guys are actually having trouble integrating trig function. So this video, I would say today's video is more like I'm just gonna review your homework assignment problems, like most of those. For some of the problems, I'm gonna walk you through like first few steps and I want you to finish the rest, okay? So I'll try to do as much as possible. So like first example, some examples are actually from, I would say it's going to be in today's assignment, and there's some from yesterday's assignment. So let's start off with the first one. This is similar to problem number 15. So that's going to be today's homework assignment. So this is similar to problem number 15. Okay, I have sine of 5x, cosine of 5x. One thing I would like to say, if you guys are getting confused with applying actual integral rules by like pattern recognition, so do one thing, just do use substitution on most of those. If the equation doesn't look like those rules we have talked about, then just better to do use substitution instead. All right, it would be easier for you to do that. Okay, for a problem like this, since both of these expressions have same exponents, so which one we should make it equal to u? For a problem like this, it doesn't matter. You can pick either or and then set it equal to u. So I'm just going to take sine function and I'm going to set it equal to u. Okay, so I already know this expression is equal to u. Let's just solve this equation, take the derivative. Derivative of sine of 5x would be 5 cosine of 5x. Cross product. So this is what I have so far. Okay, now let's see what we needed here. So the rest of the equation is cosine 5x and dx. What I have is cosine 5x dx, and this 5 is extra, so I would just divide both sides by 5. So once I do it, so my new equation after substituting everything in terms of u, this is how it's going to look like. So rest is pretty much, I would factor out 1/5. So I have u left in there. So this is where I would do normal integral. So 1 added 1 divide by the same thing. So this becomes u squared over 2 plus c, and at the end replace the original equation in terms of u. So just substitute this u part with this equation here. That would be your actual answer. Next one. So let's say I have something like this. It's secant of negative 8x times it by tangent of negative 8x, and there's dx. Okay, this one we could still do use substitution, but what I see is one of the integral rule exactly match up with this. So there is one rule that's secant x times tangent x, it's equal to secant of that angle, right? So it means I already see the pattern happening in this equation. So what I have to do is I'm just going to do pattern recognition, because think about this. Isn't it this whole thing should have derivative of this angle attached to it? Do we have that derivative there in the equation? No, it's not. So there should be negative 8 in there. It's not in there, so I will just multiply by that, top and bottom. Rest, I would just factor out the number that's needed, that's not needed. The top one would complete the pattern, so I would factor out 1/8. Integral of this whole thing. So that's going to be secant of the angle itself and plus c at the end. All right, okay. I have like so many examples to show you guys today. So again, for a few questions, I'm just going to walk you through with first few steps. And the rest, I want you to finish it, okay? All right, so let's look at another one. I have cotangent square dx. Okay, so again, if I look at my rules, I do not have anything for cotangent square. So for something like this, you have to substitute this function with another equation by using those identities. So I hope you remember cotangent square based off Pythagorean identities. So this is actually cosecant square x minus 1. Now this is just like normal equation. This is where I would just split up into two different pieces here. So I would have integral of this piece and integral of 1 here. And then just go from there. So we do have a rule for cosecant square, so you could just apply that. So that's how I would attempt this one. This is cosecant. This is the next one, and this is number 22 on yesterday's assignment. X over 2, and it's dx. Okay, you could do pattern recognition, or you could do u substitution for something like this. Both. I'll show you both. Now, before, when we had two trig functions like this one here, we had two trig functions in the original, and they both had the same degree. So we just pick one function, we set it equal to u, right? Okay, but what if there is just one trig function in the equation? Then what do we have to make it equal to u? So that's going to be the angle that would be equal to u. All right. So first I'm going to show you u substitution. Then I'm going to do pattern recognition on this side. Okay. Anyways, so I would set this part equal to u. So u is equal to x over 2. Take the derivative du over dx. I would factor out 1/2, and derivative of x would be just 1. Cross product, so it's 2 times du, it's equal to dx. This is what I have so far. Back to my original. So this is integral, this is cosecant squared, this is u, and this is dx. Okay, now I need to replace dx with this piece here. So that would be cosecant squared, it's u, it's 2 times du. Now I would factor out 2, integral of cosecant squared u and du. And we do have a rule for cosecant square, which is equal to negative cotangent. So I'm going to put negative with this too. So it's cotangent, and it's u and plus c. Finally, I would substitute u with the original expression, which is x over 2 and plus c. All right, so that's how we do by u substitution. But let's say you don't want to do that. You want to do pattern recognition. So think about this. Isn't it this is my original? That's one of the rules. Isn't it this should have derivative of this part attached to it? All right, so what's the derivative of parentheses? It's 1/2. So I would just put 1/2 over 1/2. The top one would complete the pattern. I would factor out this bottom 1/2, which you have to take a reciprocal. You need to take out the reciprocal. And then the integral of this whole piece, based off one of the rules, it's going to be negative cotangent of the angle itself. And this negative you could just multiply by 2 here. So finally you could just put it together as. So that's just going to be another way. All right. So either or. So if you feel safe using u substitution, go for that. I know it's going to be a little time consuming, but I guess it's worth it. All right. Okay. So let's say I have another example, which is number 25 on your assignment. Number 25 is cosine theta over sine theta. Okay, we do not have anything like quotient rule, product rule, anything like that. So, and there's nothing I could do to simplify. I can make cotangent, but again, we don't have anything for cotangent. So what I would do is, I'm just going to take sine function. Is it okay if I change this theta to x instead? It's less confusing. I'm just going to put it as x. How about if this is cosine x, and if I move sine x to the top, isn't it that would become -1? No. Time to do u substitution. What part you would set it equal to u? The one that has negative exponent, right? So I would say u is equal to sine x. Take the derivative, du over dx. Derivative of sine x would be cosine x. Cross product. This is what I have so far. Okay, now back to this equation here. Integral. What's cosine x? Oh, let's just substitute this part for you. So I have u to -1. I still have this part and this part. I need to replace these two pieces. What is that equal to? Cosine x times dx. What is that equal to? It's du. Okay, this is something you need to understand. Now, isn't it after getting everything in terms of u, then we just normally integrate the function by adding 1 and dividing? So let's try doing this. Let's see what happens. If I add 1 and divide by that. So what would happen here? So it's going to be 0, u to 0 over 0. Isn't it? That would become undefined if you divide by 0. Now try recalling. So whenever something like this happens, this is going to be integral of ln function. So basically, this is not needed. So what I'm going to do is, I'm just going to move u. Oh, let me just write it like this first. Okay. U to negative 1. How would you simplify? It's 1 over u. And if you see 1 over a function, that's always going to be log function integral. So if I take integral of this, 1 over u means it's ln of u. And remember, we put absolute value plus c. And the reason we put absolute value, because ln always going to be positive function, right? And finally, I would substitute this u function with my original equation, which is this one. So my answer would be, here you go. So keep in mind, anytime you try doing normal integral and the function becomes undefined because of 0 in the denominator, so that's always going to be log function integral. All right. I have 2 more to show you. So let's see. If I have tangent, I just like having x there. So tangent x. Do we have anything for tangent? Nope. This one doesn't have square either, so I can't use those fundamental Pythagorean identities either. So instead, I'll think about simplifying. So I would rewrite, let's just say this is 5x. I would rewrite it as sine 5x and cosine 5x. Okay, how do we simplify? So I'll just move the bottom expression to the top, and this becomes negative. And now, isn't it, this is normal u substitution problem? Just pick a part that has negative exponents, set it equal to u, and then just follow those steps, right? So keep in mind, just take this part, set it equal to u, and then just go from there, okay? Okay, how about the next one? Cosine x, 1 plus sine x. Okay, for something like this. Same thing. There's nothing, you can't split up into multiple fractions. So instead, what I would do is, I'm just going to leave this cosine as it is. The bottom part, I can take it to the top. This becomes negative. And now once this is negative, so I would set this one equal to u, and then I'll follow u substitution after. And anytime you would see anything, u has some negative exponent or like negative 1, and then you try adding 1 and dividing. If that becomes undefined later on, keep in mind it's always going to be ln function once you integrate. All right, so yeah, I try going over most of these examples. If you still feel like you need help on anything, you can just comment and I'll answer that. All right. Okay, thank you guys. Thank you very much.